saying, so imagine there were particles, right? And think about the forces between them. And then last year I had the opportunity to do some molecular modeling work in my classroom. So we do a lot of work on computers. And in your book, you'll see at the end a way to, or some websites that you can use to do molecular modeling with computers. And I refer to that as submicroscopic, meaning thinking on the particle level, thinking particles. So my classes are in intermolecular forces, and I'm going with the Karl-Pradick method of pulling whatever happens to be in your classroom. I really like that idea, so this is what we're doing this week. So these are just a bunch of ping pong balls, right? And I asked the kids to make predictions about what will happen if I shake it up, putting the lid on. So I do a lot of this, really simple. Right? And we talk about what it should look like if I'm going to simulate a gas versus what it's going to look like if I'm going to simulate a liquid. And I also tell them the time about that I forgot to put the lid on, right? And then what happened when the particles kind of started escaping and what that might be. But what I saw the person do, and this is the simplest thing, I got these ping pong balls off of eBay. It just has a bunch of Velcro on it. So I have big Velcro squares, little Velcro squares, and I just throw them into the mix. And I ask the kids to make predictions about what's going to happen. So I literally just throw these in there like this, kind of at random. And each of the kids makes predictions, and we talk about what's going on, we throw them in there. And some of them will notice that I have to separate them kind of as I'm putting them in there. And then I have, again, some of the small ones as well. And I shake them up again like this. Like I said, very simple. And then you get these where they're linked together. And so we use this throughout the whole unit to keep referring back to. Ideally, you could label these particles so that maybe you have ones that are labeled as ethanol, these could be labeled as, say, N2. But it's just referring back to the fact of what starts to happen to these particles, why are they sticking together. What I like too is that the smaller ones don't stick as much, but will stick in between with some of the bigger Velcro. And it's really just a physical way of talking about intermolecular forces. And again, if you put them all in there, so we talk about what this might be, you have a whole group of them that are in there, so that we have, again, just a way to refer to it. And eventually the kids will get sick of me talking about, remember the ping pong balls, right? And right now we're talking about phase changes. So I will give a kid like this many and ask them to separate them, and they have to pull them all apart. So we talk about the energy to separate the particles, and we're not breaking the bonds. But it's just when I was talking to my students otherwise, again, we were talking about it all imaginary. And I just find it kind of limitless in terms of the things that you can talk about. If you're bold, again, you can actually shake it without the lid on. The non-polar ones will escape. And then, of course, these usually kind of stay in the container. So I just use it as a model for phase changes and